This is the USS Lyndon B. Johnson, a 16,000-ton guided missile destroyer. It is the pinnacle of the United States Navy's stealth fleet, a multi-billion-dollar ghost ship engineered to look no larger than a tiny fishing boat on enemy radar. But its real crown jewels are sitting right on the bow. The twin 155mm advanced gun systems. Together, they represent the most ambitious, high-tech, and destructive naval artillery designed since the end of the Second World War. They were built to automatically load, aim, and fire highly destructive precision shells at targets up to 80 miles away, raining down devastating firepower at a blistering speed of 10 rounds per minute. It was supposed to change the face of naval warfare forever. But here is the catch. The USS Lyndon B. Johnson will enter active service without ever firing a single operational round from these weapons. Not one. In fact, no sailor will ever load an explosive shell into these breaches. No commander will ever order them to open fire on an enemy shoreline. As you watch this video, these multi-million-dollar turrets are not being prepped for combat. They are being physically ripped out of the ship's deck with heavy industrial cranes at a shipyard in Mississippi, destined for the scrap heap. How does the wealthiest military on Earth spend decades engineering a revolutionary weapon system, build a multi-billion-dollar stealth destroyer entirely around it, and then throw the whole thing in the bin before it can fire a single shot? The answer isn't a mechanical failure. The guns worked perfectly. Instead, it is a story of catastrophic political compromises, a collapse of basic economic logic, and a logistical death spiral that turned a single bullet into a $1 million nightmare. To understand why the Lyndon B. Johnson's guns were built, we have to go back to a major identity crisis inside the U.S. Navy at the end of the Cold War. For nearly a century, if the U.S. military wanted to land Marines on a hostile beach, they relied on naval gunfire support. Massive battleships or heavy cruisers would sit off the coast and obliterate enemy bunkers, artillery positions, and trenches before the landing craft ever hit the sand. But by the 1990s, those legendary World War II-era battleships were rapidly being decommissioned. They were too expensive to run, required thousands of crew members, and were vulnerable to modern anti-ship missiles. When the battleships retired, they left a massive, dangerous gap in the Navy's capabilities. If a conflict broke out, how was the Navy supposed to protect troops landing on a beach? Standard destroyer guns, the 5-inch marks found on Arleigh Burke-class ships, simply didn't have the range or the punch. They could only shoot about 13 miles. If an enemy had basic artillery or anti-ship missiles hidden 20 miles inland, the standard fleet was completely useless. The Pentagon's solution was radical. They didn't just want a new gun. They wanted an entirely new kind of warship. It started under the project name DD-21, the destroyer for the 21st century. This project eventually morphed into the Zumwalt class program. The vision was highly aggressive, a surface combatant that could slip into shallow coastal waters completely unseen, parked right under the enemy's nose, and use a revolutionary artillery system to strike targets deep inside enemy territory with pinpoint accuracy. The ship itself was a marvel of futuristic engineering. It featured a radical tumble-home hull, where the sides of the ship slope inward from the waterline, rather than outward like a traditional boat. Combined with a completely enclosed, flat composite deckhouse that hid every single radar dish and antenna, a 16,000-ton warship was given the radar signature of a tiny wooden fishing trawler. But the entire ship was ultimately a delivery mechanism for the weapon system flanking its bow. The Advanced Gun System, or AGS, developed by BAE Systems. The AGS was a 155mm liquid-cooled artillery piece. The Navy didn't want standard manual loading rooms where sailors lifted heavy gunpowder bags by hand. The AGS was designed to be 100% automated. Deep within the belly of the ship, beneath the heavy deck armor, sat a massive, automated magazine. Robotic hoists would select a shell, lift it into the turret, ram it into the breech, and fire, all without a single human being ever touching the weapon. Because the barrels were water-cooled, they wouldn't overheat. A single zumwalt-class destroyer carrying 2 of these guns could maintain a continuous firing rate of 20 rounds per minute. If you had a 3-ship squadron, you could rain 60 heavy artillery shells onto a target every single minute. But traditional unguided artillery shells suffer from a fundamental law of physics. The further you shoot them, the more the wind, atmospheric pressure, and gravity push them off target. At 80 miles out, a standard shell would miss by miles. To solve this, the engineers didn't just design a new gun. They designed the most advanced, complex bullet in human history. This is the LRLAP, the long-range land attack projectile. Calling it a bullet or an artillery shell doesn't really do it justice. The LRLAP was essentially a hybrid between an artillery round and a guided missile. It was massive, measuring over 7 feet long and weighing more than 220 pounds. When the advanced gun system fired, the LRLAP would blast out of the barrel like a conventional shell to clear the ship. But once it reached the apex of its flight high in the atmosphere, its rocket motor would ignite. Suddenly, the shell would accelerate, stretching its trajectory across the sky. As it began its descent toward Earth, canard fins would deploy from its nose. Using an onboard, hardened GPS and inertial guidance system, the LRLAP would actively steer itself through the air, adjusting for wind and weather. The accuracy was staggering. Whether you fired it from 10 miles away or 80 miles away, the LRLAP was designed to impact within a few meters of its coordinates. It could dive almost vertically, punching straight through the reinforced concrete roofs of underground bunkers. Even better, the gun and the shell were programmed to perform a trick called MRSI, multiple round simultaneous impact. Because the ship's computer could instantly calculate different flight paths for different shells, the AGS could fire a sequence of rounds at entirely different angles and speeds. The first shell would be launched at a high, looping trajectory. The next shell would be fired seconds later at a lower, faster trajectory. The result? Up to 8 different shells, fired at different times, would all arrive at the exact same target at the exact same second. An enemy position would go from complete silence to being struck by 8 massive explosions simultaneously, giving them absolutely zero time to run for cover. On paper, it was the ultimate weapon. It offered the precision of a Tomahawk cruise missile, but at a fraction of the cost, with a magazine that could keep firing for hours. The key phrase there, however, was at a fraction of the cost. When the Navy began developing the LRLAP, the economic math was simple. The plan was to build a fleet of 32 Zumwalt-class destroyers. With 32 ships, each packing 2 guns, the Navy would need to purchase thousands upon thousands of LRLAP rounds to fill the magazines and maintain training stockpiles. In manufacturing, this is known as economies of scale. The more units you produce, the more you can spread out the massive initial costs of research, development, specialized tooling, and factory setups. Originally, the Navy projected that each LRLAP smart shell would cost around $25,000 to $50,000. While that is vastly more expensive than a dumb, unguided World War II shell, it was an absolute bargain compared to a Tomahawk cruise missile. which costs over $1.5 million per shot. For a decade, the program marched forward under these assumptions. The shipyards laid down the hulls, BAE Systems built the complex automated gun turrets, and Lockheed Martin finalized the smart guidance systems for the LRLAP. But while the engineers were solving the laws of physics, the politicians and accountants in Washington were completely destroying the economics. As the 2000s rolled on, the zumwalt program ran into a wall of brutal reality. Building a stealth ship from scratch with an untried hull design, a brand new integrated power system, advanced dual-band radars, and automated robotic ammunition handling was far more difficult than the Navy anticipated. Costs didn't just rise, they exploded. The price tag for a single zumwalt-class destroyer ballooned to over $4 billion, and that didn't even include the billions spent on research and development. Sensing a massive political disaster, Congress panicked. To save money in the short term, they did the exact thing that guarantees long-term economic failure. They cut the number of ships they were going to buy. First, the fleet of 32 was cut to 24. Then, as costs kept climbing, it was slashed to 7. Finally, in a desperate bid to cap the bleeding, the Pentagon gutted the program entirely, locking in a final fleet size of just 3 ships: the USS Zumwalt, the USS Michael Mansour, and the final vessel, the USS Lyndon B. Johnson. When you slash a production run from 32 ships down to 3, the math behind the ammunition doesn't just change, it completely collapses. Because Lockheed Martin still had to recoup the immense cost of designing the rocket motors, the GPS guidance tracking, and the custom manufacturing lines, but could now only sell a tiny fraction of the ammunition. The price per shell skyrocketed into absolute absurdity. By 2016, a single LR-LAP shell was projected to cost between $800,000 and $1 million. Let that number sink in. One single bullet, fired from a deck gun, costing $1 million. If a zumwalt destroyer engaged an enemy coastline and fired its guns at their full automated speed for just 2 minutes, it would burn through 40 rounds. That brief 2-minute barrage would cost the American taxpayer $40 million. For that same price, the Navy could buy dozens of Tomahawk cruise missiles, which carry far larger warheads, travel hundreds of miles further, and don't require risking a $4 billion stealth ship near an enemy coast. The economic logic had inverted. The gun that was designed to be a cheap, high-volume alternative to missiles had become so expensive that firing it was a fiscal crisis. In November 2016, the U.S. Navy did the only logical thing left to do. They officially canceled the procurement of the LRLAP ammunition. They stopped the program dead in its tracks. But this cancellation created a brand new, deeply embarrassing problem for the final ship in the class, which was completed in 2022, the USS Lyndon B. Johnson. When the Navy canceled the smart ammunition, the immediate question from critics and lawmakers was obvious. Why not just shoot normal bullets? After all, the U.S. Army and Marine Corps have been using 155mm artillery for generations. The standard M777 howitzer fires a 155mm shell that costs a few $100s. If the Lyndon B. Johnson's guns are 155mm, why not just load those standard Army shells into the destroyer's magazines and use them instead? It sounds like a simple, common-sense fix, but in naval engineering, nothing is ever that simple. The advanced gun system was a victim of its own specialized design. It wasn't just a barrel, it was an enclosed, interconnected ecosystem. First, there was the physical design of the gun barrel itself. The AGS was built with a specific rifling twist, and a unique elongated chamber designed strictly to handle the massive 7-foot-long LR-LAP rocket-assisted projectile. A standard Army 155mm shell is much shorter and shaped completely differently. If you loaded a standard Army shell into the AGS breech, the barrel wouldn't be able to spin it correctly or seal the pressure properly. The shell would tumble out of the barrel and drop uselessly into the ocean, or worse, detonate inside the gun. Second, and more importantly, was the automated magazine. Remember, this ship has no crew inside the gunroom. The entire handling system, from the deep storage racks to the loading trays, the elevators, and the ramming arms, was custom-built down to the millimeter around the exact dimensions and weight of the LR-LAP shell. To make the ship fire standard Army ammunition, the Navy would have to completely rip out the multi-story automated handling system inside the belly of the ship, redesign the robotics from scratch, and install an entirely new mechanical ecosystem. And even if they spent hundreds of millions of dollars doing that, the result would be a total failure. Standard Army artillery shells don't have rocket boosters or GPS guidance. If you fired them out of the Lyndon B. Johnson, their range would drop from 80 miles down to less than 15 miles. The Navy would be right back where they started, a multi-billion-dollar stealth ship forced to sail dangerously close to a hostile beach just to fire basic, unguided artillery shells. The USS Lyndon B. Johnson was caught in a perfect logistical trap. It was a brand new, ultra-futuristic warship completed in 2022, carrying two massive, state-of-the-art weapon systems that were literally incapable of firing any ammunition currently in existence on Earth. The guns were completely dead, and the Navy had to figure out what to do with a ghost ship that had no teeth. This brings us to the radical, high-stakes gamble to save the USS Lyndon B. Johnson. The Navy realized that leaving these useless guns on the deck was an ongoing embarrassment. But more importantly, the strategic landscape of the world had completely changed since the ship was designed in the 1990s. The threat wasn't landing Marines on beachheads anymore. The threat was the rise of near-peer naval adversaries in the vast expanse of the Pacific Ocean. The Navy didn't need close-range artillery support. They needed ultra-long-range, unstoppable offensive strike power. So the Navy made a definitive choice. They stopped trying to fix the guns. They decided to eliminate them entirely. The USS Lyndon B. Johnson arrived at Huntington Ingalls Industries shipyard in Pascagoula, Mississippi, and was moved into dry dock. Shipyard workers began a massive, invasive structural surgery. They are using heavy industrial cutters to slice the twin advanced gun systems completely away from the deck house, lifting the massive turrets off the hull. In the deep, empty space left behind by the automated gun magazines, the Navy is installing the conventional prompt strike weapon system. This isn't your standard vertical launch system for common missiles. The CPS is a massive specialized launcher designed to hold the military's latest cutting-edge weapon, hypersonic boost glide missiles. Developed in a joint program with the U.S. Army, these missiles are massive. Each launch tube will carry an advanced payload module packed with 3 hypersonic weapons. Because the Lyndon B. Johnson has so much space inside its bow where the old gun machinery used to live, it can carry multiple modules. The operational concept is terrifyingly effective. The ship uses its stealth hull to loiter undetected in the deep waters of the Pacific. If a high-value, time-sensitive strategic target is identified, like an enemy command bunker, a radar installation, or a mobile missile launcher thousands of miles away, the Lyndon B. Johnson can launch a CPS missile. The missile's massive rocket booster blasts it into the upper atmosphere. Once there, the hypersonic glide vehicle separates, plunging back down toward Earth at speeds greater than Mach 5. more than 5 times the speed of sound. At that speed, the weapon flies along an unpredictable atmospheric trajectory, making it virtually impossible for modern air defense systems to track or intercept. It can strike a target deep inside enemy territory within minutes of the launch command. The transformation changes the entire identity of the ship. The Lyndon B. Johnson is transitioning from a failed land attack gunboat into the Navy's premier long-range hypersonic strike platform. The story of the USS Lyndon B. Johnson is a stark reminder that the most dangerous enemy an advanced military program faces isn't found on the battlefield. It is found in the conference rooms of the Pentagon and the halls of government, where budgets change, priorities shift, and the laws of economics hold absolute veto power over the laws of engineering. The advanced gun system was an engineering masterpiece that performed exactly how it was designed to. But because the institutional strategy changed around it, it became the most expensive, highly sophisticated piece of scrap metal in naval history. By the time the Lyndon B. Johnson finally joins the active fleet, its historic guns will be gone, replaced by a weapon system the ship's original designers never even envisioned. It will finally have its teeth, but it took $1 billion lesson in economic reality to get them. Thanks for watching. If you want to dive deeper into the engineering failures and outliers of naval history, make sure to hit that subscribe button, leave a comment below about what you think of the Zumwalt class rebirth, and we'll see you in the next video.